So we're moving on to a new chapter. This will be the only new lesson this week due to swag week. So this is just part 1 of 5.1 notes. We'll finish up these notes next week. So let's just jump into 5.1, nth roots and rational exponents. So just a quick overview of 5.1. You can extend the concept of a square root to other types of roots. For example, 2 is a cube root of 8 because 2 cubed equals 8. In general, for an integer n greater than 1, if b to the n power equals a, then b is an nth root of a. So this is just an example of what this is saying right here. So if b to the n equals a, then b is an nth root of a. So 2 cubed equals 8, so 2 is a cube root of 8. So that's essentially what that's saying, but that applies to more than just cube roots. It applies to square roots, fourth roots, fifth roots, so on and so forth. An nth root of a is written as the nth root of a, where n is the index of the radical. You can also write an nth root of a as a power of a. If you assume the power of a power property applies to rational exponents, then the following is true. So if I have a to the 1/2 power raised to the 2nd power, if you have a power raised to a power, we got to go back to our exponent rules. We would multiply these two things. So that's what this is doing right here, 1/2 times 2, which is just 1. So a to the 1/2 squared is just a. Same thing down here. A to the 1/3 cubed is also just a. A to the 1/4 to the 4th is just a. Because a to the 1/2 is a number whose square is a, you can write the square root of a equals a to the 1/2. Similarly, the cube root of a equals a to the 1/3, and the fourth root of a equals a to the 1/4. In general, the nth root of a equals a to the 1 over n for any integer n greater than 1. So this is just telling us that anytime we have a radical expression, we can rewrite it with an exponent. So if I have the 8th root of a, I can rewrite that as a to the 1/8. The denominator of that fraction exponent, the rational exponent, is just my index and vice versa. So the 8th root of a is just a to the 1/8 power. So keep that in mind. Anytime we have a radical expression, we can rewrite it using rational exponents. So let's talk about real nth roots of a. Let n be an integer, n is greater than 1, and let a be a real number. So we're talking about the nth root of a. A is just our numbers, the n's are roots. So let's talk about this left column first. So let's talk about when n is an even integer. So I'm taking an even root of our numbers. If the number that I'm taking the even root of is less than 0, then there are no real nth roots. Remember, when we're talking about real numbers, we cannot take an even root of a negative number. All my negative numbers are less than 0. So if I'm taking the even root of a negative number, I don't have any real nth roots. Now remember, I can have imaginary roots, but right now we're just talking about real numbers. So I don't have any real nth roots. If my a value is 0, then I only have one real nth root. Because if I take any root of 0, I'm just going to get that one number 0 back. Any root of 0 is just going to be 0. So I just have one real nth root. And then let's talk about positive values. If a is greater than 0, then I have two real nth roots. We have to account for that positive and that negative value. So plus or minus the nth root of a equals plus or minus a to the 1 over n power. So I'd have 2 real nth roots. So that's all for if n is an even integer. Now let's talk about if n is an odd integer. So if my a value is negative, it's less than 0, I am able to take the odd root of a negative number. So I'll get 1 real nth root if my a value is less than 0. The nth root of a equals a to the 1 over n power. Same thing with the even integer. Even if n is an odd integer and a equals 0, I'm just going to have that 1 real nth root of 0. That one doesn't change because, once again, any root of 0 is just going to be 0. And then lastly, when my a value is positive, it's greater than 0, I'm just going to have 1 real nth root of a equals a to the 1 over n power. So I would have this chart somewhere in my notes. That way I know how many roots I'm going to have each time I'm dealing with this. So let's look at some examples. It says find the indicated real nth roots of a. So we're going to be using this chart to help us out, and then we're going to actually find the roots. So it wants us to find the third root, the cube root of negative 216. So let's look at our n value. Our n value is 3. You got to ask yourself, is 3 an even or an odd number? It is odd. And then I have to ask myself is if a is less than 0, equal to 0, or greater than 0. Negative 216 is less than 0. So my n value is odd. A is less than 0. So I know I'm going to have 1 real nth root. Now I actually need to find the cube root of negative 216. Before we do that, I want you to get a little practice asking yourself, what's another way I could write the cube root of negative 216 with an exponent? And that would just be negative 216 to the 1/3 power. Remember, our index just becomes the denominator of my rational exponent. So now I'm asking myself what number times itself gives me negative 216, and that number would be negative 6. If I do negative 6 times negative 6 times negative 6, I get negative 216. So negative 6 is my cube root of negative 216. On your assignment, I do want you to do all of this. I want you to tell me if n is even or odd, if a is less than, equal to, or greater than 0, and how many roots you're going to have, how many real roots. And then I want you to go ahead and find the root as well on your assignment. I want you to do all of that. So let's look at letter B. Once again, start off with the n value. N is 4, so that's an even number. N is even. A is 81, that is greater than 0. So n is even. So I'm in this left column over here. A is greater than 0, so I know I'm going to have 2 real nth roots. I know I'm going to have 2 real nth roots. Excuse me. So I'm finding the 4th root of 81, or 81 to the 1/4 power. Those are the same thing. So I'm asking myself what number times itself times itself times itself gives me 81. Well, we know there's 2 values that give me 81 when I multiply it by itself, by itself, by itself. I know positive 3 does, and so does negative 3. 3 times 3 times 3 times 3 gives me 81. Negative 3 times negative 3 times negative 3 times negative 3 also gives me 81. So now my two real nth roots are positive 3 and negative 3. Once again, I want you to do all of this on your assignment. Okay, let's move on. Let's talk about rational exponents. A rational exponent does not have to be of the form 1 over n. Other rational numbers, such as 3 over 2 and negative 1 over 2, can also be used as exponents. Two properties of rational exponents are shown below. I would probably have these properties written down in your notes. It says let a to the 1 over n be an nth root of a, and let m be a positive integer. So if I have a to the m over n, I can break it down like this. This helps me because I know a to the 1 over n power, I can rewrite with a radical, the nth root of a. So it's just the nth root of a raised to that m power. And hopefully you guys will see that a little bit once we do some examples. This one is very similar, it just has one difference, has that negative exponent. Once again, we have to go back to our exponent rules. If I have a negative exponent, to make it positive, I change its position in the fraction. So if I have x to the negative third over 2, to make that exponent positive, I change its position in the fraction. So I just move whatever has a negative exponent from either the numerator to the numerator to the denominator, or from the denominator to the numerator. So if I have 2 over x to the negative second power, that would just become 2x squared, changing its position in the fraction. So that's what you have to do first if you have a negative exponent. Change its position in the fraction. And then the rest is just the same as this first property. It's just all in the denominator now. So you break it down into a to the 1 over n to the m power, and then you do the nth root of a to the m power. So once again, I'd have those properties written down. And now let's look at some examples. It says evaluate each expression. So for letter A, I have 16 to the 3/2 power. Based on this property, this first one, I can break this down into 16 to the 1/2 power raised to the third power. Because if I multiply those two exponents, I'd get back to 3 over 2. Once again, having it like this helps me because I can now write that with a radical. If I have 16 to the 1/2, that's just the square root of 16. I now know what the square root of 16 is. It is 4. And now I can evaluate what 4 to the third power is. 4 to the third is 64. 4 times 4 times 4. So letter A would be 64. So that's how we're approaching these types of problems. On your assignment, on problems like this, it's going to tell you to do it without a calculator. So I actually want you to do it without a calculator. Do not use a calculator on these types of problems. So let's look at letter B now. Letter B is going to be like our second property since we have that negative exponent. So before I do anything else, I have to make that exponent positive by bringing it to the denominator. Just like that. And now I can break up the denominator to be 32 to the 1/5 power to the third power. 32 to the 1/5 is just telling me to do the 5th root of 32. So I'm asking myself what number times itself, times itself, times itself, times itself gives me 32. That number is 2. And now I can raise that number to the third power. So 2 to the third would be 2 times 2 times 2, which would give me 8. So my answer for letter B is 1 over 8. So once again, I want you doing those without a calculator on your assignment. Hope all of this made sense. If it did not make sense, please make sure you're asking me questions to better understand the material. Here is our assignment for today. This is due on Thursday, the 25th. Hope you guys have a good day. Once again, if you guys have any questions, make sure you're asking.